Okay, now we're going to go through and cover the properties of logarithms. So here what we're going to first look at is mapping. Okay. So if we have a log, remember this is the base, the answer, and the power. Subscript is the base, which you're taking the log of is the answer, and logs are equal to powers. So if we switch forms, this is a to the power of y equals x. Okay. So here on number 1, we've got our base, which is 2 to the power of 6 equals 64. Again, this is base, answer, power. So on number 2, your base is 3, your power is -2, equals your answer, which is 1/9. On 3, this is base is 2, power is 0, equals answer, which is 1. On number 4, we're going the reverse way. So here we have our base, our power, our answer, and we're going to switch back to log. And remember, it's base, answer, power. That allows you to write it. So this is log, your base, which is 6, your answer, which is 36, equals your power, which is 2. On number 5, this is log, your base is 2, your answer is 1/8, equals your power, which is -3. On number 6, this is log, your base, which is 10, which you do not need to write, but you can. Your answer, which is 0.001, equals your power, which is -3. Okay. In the next section, we're just going to get practice evaluating logs. So here, this would be 2 to what power gets you 9. Well, since that is not a power, since 9 is not a power of 2, we need to use the change of base formula. So change of base formula, you take the log of what you were originally taking the log of and divide it by the log of your base, which is 2. And then that can get plugged into your calculator. So on that one, we've got the log of 9. Make sure you close your parentheses, divided by the log of 2. So that is approximately 3.170 if you went to 3 decimal spots, because that 9 would change that 9 into 70. Okay. Number 8, we don't need a calculator for. This is 3 to what power, 13 to what power gets you 13. Obviously, that's equal to 1. However, you could pop that in. You can do log of 13 divided by log of 13, and you'll find out that is 1. Okay. And on number 9, 3 to what power gets you 1 over 27. So here, if we get rid of the 1 for a second, 3 to what power gets you 27? Well, that's 3 times 3, which is 9 times 3, which is 27. So that's the third power. And to make it go down below, that would be the negative third power. But again, you could do a log of 1 divided by 27 divided by the log of 3, and you would get -3 as your answer. Either way. Okay. Then in problem number 11 through 12, here we're trying to write these as a single log, so we're going to use our properties of logarithms. So here when you add logs, you take these values and you multiply. So this is the log of 8 times 3, which is actually the log of 24. On number 11, since we're subtracting, You divide these values, so this is the log, base stays the same, and this is going to be a fraction, 5 divided by 3. So it's the log of 5/3. On 12, in order to use the addition here, we can't have any numbers out in front, so we're going to need to bring the 4 up to the power. Okay, so this is actually log base 3 of x to the 4th plus log base 3 of 7. And now we can go ahead and multiply. So this is log base 3 of 7x to the 4th. Okay. In questions 13 through 15, we are going to go the reverse order, which we just did. So we're going to split this up. So you're looking for things that are multiplied or divided together. So we've got two logs that are multiplied, two values that are multiplied together here. So we're going to break this up into two logs. Log base 4 of x squared plus log base 4 of y cubed. So you take the log of each of those, and then the powers are going to move out in front. So this is 2 log base 4 of x plus 3 log base 4 of y. And now the reason why those powers are coming out in front of each of those logs is because we could technically write this as x times y times y times y. So here, when you do that, you're going to have the log of x plus the log of x. Well, how many log of x's do we have? We have 2 log of x's. Here you'd have log of y plus log of y plus log of y. Well, how many log of y's would you have? You would have 3 logs of y, which is why those powers end up coming out in front. Okay. On 14, since we have a power there, we can bring that out in front. So this is 2 log x over 3. And then since this is division, we can write this as 2 log of x minus, this 2 would go with both logs, so that's 2 log of 3. Or, since the 2 goes with both, we could just list it out in front of parentheses once, rather than having it distributed to both. Both of these would be acceptable answers. And there's actually a third variation. Had you distributed this to x squared over 3 squared, which would have been 9, you could have written this as 2 log of x minus log of 9. Any of those would have been acceptable answers. Okay. On 15, here we've got 2 times this log, and what we really should recognize is the square root is actually the 1/2 power. You need to switch the radical to a power. So we're going to split this up into 1, 2 logs. So this is log base 3 of 2. Since it's multiplication, we add log base 3 of x to the 1/2. But then that 1/2 has to go out in front. So this is log base 3 of 2 plus 1/2 log base 3 of x. So that takes care of all the log properties.